name is Jared Olivares. I'm an electrical engineering student here at Texas State University. Today I'll be going over Kirchhoff's current laws, abbreviated as KCL. This is my second video on my YouTube channel. I did a video prior on Ohm's law, which is pretty close to what we will be going over today. I just want to go over Kirchhoff's current laws, just to give a bit more context as far as how circuits and conductors work. So as far as Kirchhoff's current law, basically what it is going to be total current flowing in, just right here, and total current flowing out. So I already wrote the formula right here. It has to equal to 0. So all of these things that you see here, I tried to make it not look as complicated as possible. All of this is going to give a 0. So what I did here was, you can see this little point right here where all these little arrows or wires go through, whatever. That's going to be our junction. That's our meeting point right there. That is where our two conductors meet. Well, the 2 is just the base. It can be a lot more, but as far as for today's video, we'll start at 2. So in here you see I1, I1, I2, and I3. Those are ours going in. So these are all pluses. So keep in mind these 3 numbers. These are going to be pluses. I4, I5, and I6. These are going to be our negative numbers since these are leaving. You can see these are coming in. These are going out. So these all going out have to be negative numbers that all cancel out the positive numbers. So we have, let's say, 10 amps here, 10 amps here, 10 amps here. We have, let's say, 8 amps here, 7 amps here. That's going to be 15, so it'll be another 15 in here to give us 30 on this end. So it's going to be 30 here, 30 here. But the thing is, since these are leaving, all of this right here is leaving, this will be a negative 30. These are all going along, so this is a positive 30. So positive 30 plus negative 30 would give us 0. So that's what way that you can do it. You have to add I1, I add I2, and I3. And you would have to subtract I4, I5, and I6. So you can add all of these up and then subtract them. So that's one way that you can do it. These are 2 ways that I wrote that would both work perfectly. I also did a little circuit for demonstration. I apologize. A little circuit for demonstration here, which would be, it's the most basic one that I could draw, so that I can illustrate it for you better. But this is going to be 50 amps. It'll give us an initial push of 50 amps, and we'll be having one of our amps going this way, which would be leaving. As I mentioned above on this prior demonstration, this is going to be a negative. So we can just write negative on there. So let's say that we start with 50. We have to remember that it has to give a 0 from the initial 50 and from 20. So we have 2 factors here. So we have to calculate for I3. What would I3 give us? So with the initial 50, we realize that these are leaving. So it's going to be negative. So it's going to be negative 20A. So how do we get 0 from 50 and from negative 20? So negative 20, we have to add negative 30, which will give us I3. So we can do negative 30 on here as for I3. And negative 30 plus negative 20 would give us negative 50 plus 50 would equal to 0. So that's basically Kirchhoff's current law summarized on a 4-minute video. I like to keep my videos around the 4-minute mark. If you guys want me to go over a more elaborate demonstration, one going into with more resistors and other factors, then you can go ahead and drop that in comments. But it is a pretty just average demonstration as far as to how Kirchhoff's law works. Have a good day.